Hello, everyone. Welcome to another installment of Brain Breakers. Today, the problem is what uses more power, two lights or one? Now, obviously, this is a channel about counterintuitive and interesting problems. So, if it was just the most basic intuitive response, it wouldn't be much of a video. So, no prizes for guessing what the answer ends up being. But let's take a look at why that is to really understand it. So specifically what we're talking about here are two lights in series. You can see on the left we've got just a single light versus on the right two lights that are connected end to end, meaning that they are in series. That is specifically what we're talking about today. We'll also show another example, but we'll see. So another assumption we're making is that we are considering these lights to be ohmic. So ohmic meaning that the resistance stays constant, meaning that changing the voltage or the current will not change the resistance, and hence it responds in a linear fashion. So as I increase the voltage, well, the current increases proportionally, non-ohmic being just not that. So changing the voltage will change the resistance. If you look at down the bottom at a typical globe behavior as a voltage current graph, well, you can see that at a certain point it starts to become fairly linear, just like that. So we'll treat it as approximately ohmic in that region, and it just makes things a bit easier to analyze. All right, so let's get into the maths. It's not very difficult maths, but it is just maths that we need to look at. So what we're first going to say is that both batteries are going to supply the same voltage in both scenarios, because obviously we don't want to change that. We can say that the resistance in the circuit on the left is just going to be R. It's just that resistor, or that light globe having that ohmic resistance. And on the right, we are going to have a total resistance of 2R because they are both in series, and therefore their resistances just add together, hence a total of 2 times R. Now, we also know that power can be calculated as V squared on R, so therefore we calculate the power for both. P, the power 1, is just going to be equal to V squared on R, and power 2 is just going to be V squared on 2R. You can clearly see that these can be compared together, and I just get that the power in the second circuit is half that of the power in the first circuit. So therefore I've answered the question, haven't I? The second circuit with two lights has actually used less power, or will use less power than the first, which is somewhat counterintuitive because most people would assume, well, I've got an extra light, so I therefore must be consuming more energy. And power is just the amount of energy per unit time, the rate at which energy is being used. So we've figured it out mathematically, but often I don't like just doing that because a lot of this maybe is just us taking these formulas for granted. So let's try and get a little bit more of an intuitive response. So let's really dive into where this counterintuition comes from, because I assume you'll be just like me in thinking, well, two light globes, that requires probably 2 times the energy, and it's counterintuitive to realize that it requires half the energy in the end, which is an interesting outcome. And I think this counterintuition lies in the idea of resistance itself. What is resistance? We kind of tend to think of it as a load, right? And a load seems like it should require extra energy to overcome. And actually, it's the almost the opposite of that. It does require an extra force, an extra pressure, an extra voltage to overcome those loads, but that doesn't mean that the resultant energy is greater. Let's nail down what a resistance actually is. Resistance is quite literally just a resistance to current flow. It is a way of preventing current flow. Yeah. Let's use the analogy of water. And you can see that a way that we do this all the time is with a tap. I can increase the resistance to water flow by just simply turning a tap. And you can see that that plunger or washer starts to shut off the flow. Whereas I can reduce the resistance by turning it on and allowing more flow to eventuate. If we look at this, if we look at me turning my own kitchen sink tap on, you can see that as I turn it off, well, that flow is reduced because I create a greater resistance against the flow. And you can probably see there that in the end result, the energy of this diminished flow looks a lot less than the energy of the little resistance flow. Yeah, so adding resistance, yes, requires a greater force to overcome. But if I keep that force the same, well, of course, then the resultant energy of that flow will have to be diminished. So let's have a look then at what this looks like via a simulation just to show how it works in actuality. I've used the FET Colorado website. It's really handy for doing some really basic simulations like you can see in front of you here. You can very clearly see that I have both the circuit with a single light globe and with two light globes, obviously in series. As you'll notice, obviously the current in the second one is half that of the first one. Since the voltage is the same and we know that power equals voltage times current, well then all we have is half the power. Yeah. The great thing about this simulation as well is you can see the difference in light energy as well. You'll see that in the first one, the light globe is obviously glowing a lot stronger than the two light globes in the second one. And if we calculated the light energy coming out of the two bulbs in the 2 series resistor circuit, then we'd see that those are actually outputting a quarter of the energy of that single light globe in the left circuit. Yeah, because of course, if we are consuming less power, well, of course, we're not just getting any energy for free here. We are just actually producing less light energy. If we then see just the alternative example where we have two light globes in parallel, well, then, of course, in that case, both of those light globes, if treated as a constant resistor, receive the same voltage, in which case the current has to be doubled out of the battery to supply the same current through both of them. And so two light globes in parallel will use double the power as we might intuitively expect. But of course, that series one is counterintuitive. And we'll also notice that in that parallel circuit one, the light globes will shine with the same light energy as the single light globe. So yes, two light globes in series will actually use less power than one. Hopefully that was interesting to you then, and hopefully you learnt a lot from that. Thanks for watching.